Alright guys, so today's lesson is about oxidation number. Right? In redox, we know that when I undergo oxidation, okay, it means an increase in oxidation number. When I undergo reduction, it means decrease in oxidation number. But before that, we actually have to know what's the meaning of oxidation number first. And to make it simple, just think oxidation number as charge. Hey, what's the meaning of charge? Okay, you remember about the formation of ion we learned in Form 4, right? For example, sodium atom donate electron that become Na+. Alright, so when I have an ion, usually they have charge. Okay, so if I ask you what's the oxidation number of sodium ion, very simple, because sodium ion has a formula of Na+. So the charge here Na+, plus means the oxidation number is +1. Okay, so if I ask you what's the oxidation number of magnesium ion, very simple, you know, formula of magnesium ion is Mg2+. So the oxidation number +2. Aluminium ion, Al3+, so oxidation number +3, as simple as that. Okay, ion, chloride ion, Cl-, so -1. Oxide ion, 2-, so it's -2. Nitride ion is a 3-, so oxidation number is -3. So very simple, basically oxidation number means charge. Okay, and only ions have charges. Only ions have charges. Alright, elements do not have charge. Elements do not have charge, yeah? So please take note. Alright. Now, we have looked at this simple example. Now, we are going to look at polyatomic ion. What is the meaning of a polyatomic ion? Okay, I give you a comparison. Na plus versus SO4 2-. Okay, right. Now, what's the difference? Na plus, this ion is made up of one element only, one type of element, whereas SO4 2- is made up of sulfur bonded with 4 oxygen. So I have 2 different elements in here, right? So this is a polyatomic ion. Okay, it is made of more than one atom. Now, for polyatomic ion, what is the thing that you have to take note is the SO4 2-, it doesn't mean that sulfur has a -2 charge and oxygen has a -2 charge. What does it mean is, when I write SO4 2-, it actually means this is an ion made from 1 sulfur bonded to 4 oxygen. Okay, like you're very scared to be alone, so you gang up with your friends. Okay, so you form maybe a boy band, a Korean boy band or something like that. Okay, right? Then collectively, all of you together share a charge of 2-. So when I say your charge is 2-, it means this 2- charge is after you, all your charges add up, it total to 2-. Alright, it's not each and every one of you 2-, no. It's all of you charge add up equals 2-. Okay, so now manganate ion is another example of polyatomic ion. It's made of manganese, alright, and 4 oxygen. Then when I write the formula for manganate, I write as MnO4, and this entire thing, negative means everything add up together, their charge is -1. Okay, so if I ask you, what is the oxidation number of a manganate ion? It means this whole thing add up, their charge is -1, oxidation number -1. But if I ask you just purely the manganese in here, okay, then it is not -1. Later, we'll see how to determine, okay, the oxidation number of manganese if given this thing. Okay, next, chromate ion means 1 chromium bonded with 4 oxygen, and all of them share oxidation number of -2. It total up to -2. Sulfate means 1 sulfur together with 4 oxygen, all charges add up to -2. Okay? Alright, so this is about oxidation number. Basically means the charge on the ion. Alright? Okay, and remember, oxidation number or charge, okay, only ions have charge. Elements, no matter who you are, your oxidation number is always 0. So when I have element sodium, 0. When I have elemental bromine, it's also 0. What else? Let's say I have oxygen, okay, oxygen also 0. Or maybe I have chlorine element, also 0. Or maybe I have magnesium, also 0. So two things very important now. If you're element, you have no charge. Your oxidation number is always 0. Whereas if you're an element, your oxidation number is a charge. That's it. Settle. Right, if you ask me, teacher, do I need to memorize all the oxidation number? Okay, you have already memorized them when you do ECS. So when you memorize ECS, you already memorize Na+, K+, Ca2+. So just continue to use that one, okay? The charge is the correct charge to memorize. Alright, very simple. Now, you know the concept of oxidation number already, and you might also be aware that the oxidation number of most of the ions, are almost constant and never change. For example, for sodium to form an ion, sodium can only form Na+ ion. It's impossible, almost impossible for Na to form Na2+ ion. Okay? For magnesium, also same thing. You will rarely see Mg with a charge of plus. It's almost impossible. So the oxidation number is almost fixed already. But there are some substances, they are very special. They can have more than one charge. That means when they form ion, they form more than one type of ion. So what are they? Okay, what are they? They are the transition metals. What are examples of transition metals? Okay, iron. Okay, iron can sometimes be Fe2+, can sometimes be Fe3+. So if you have an iron 2 ion, then the oxidation number is +2. If you have iron 3 ion, then the oxidation number is +3. As simple as that, okay? You also follow back the charge. Next, these two special case is more special because you somehow have to memorize. And what are they? Okay, it is oxygen in a compound, or to be more specific, is actually the oxide ion. Okay, oxygen in a compound or oxide ion. Now, most of the time, oxide ion, O2 minus, so it has a charge of -2. So the oxidation number is also -2. So remember, most of the time, oxide is -2. So for example, when I have MgO, so if I ask you what's the oxidation number of oxygen in this compound, what's the oxidation number of oxide ion? It will be -2. So in the zinc oxide, okay, this oxide, the oxidation number is also -2. Except for one compound, and that compound is H2O2. Okay, in here, the oxygen carry a charge of only -1. This is something you have to memorize. In H2O2, oxygen is -1. Okay, memorize this. The second thing I have to memorize is about hydrogen. Where do we usually see hydrogen? Acids, right? Hydrochloric acid, nitric acid, and sulfuric acid. Okay, so in all of these cases, the charge of hydrogen ion in a compound is always +1. Alright, because they always exist as H+. So remember, hydrogen is most of the time +1, except when it is bonded with a metal. So for example, this case, I have sodium aluminum hydride, sodium aluminum hydride. You see my hydrogen is now bonded to sodium and aluminum metal. Alright, so when hydrogen is bonded to metal, then the charge shouldn't be a +1, it should be -1. Okay, so short summary for oxidation number. What was the short summary? Okay, rule number 1 is all elements, their oxidation number is 0. Okay, summary number 2. Okay, all the ions have charge and their charge equals to their oxidation number. Okay, for ions, the oxidation number is the charge. Okay, and rule number 3 is about hydrogen and oxygen. Hydrogen most of the time is plus. Okay, oxygen is most of the time 2- when they're in a compound. But what is the exception? The exception is in a metal hydride, hydrogen should be -1. Okay, and in hydrogen peroxide, oxygen should be -1. Okay, this is a short summary. So now we're going to look at the calculation part. To see how this oxidation number will work. Okay, you may take a break, get a sticky note and copy this rule in the sticky note and paste it. Okay, so that you remind yourself these are the important thing when it comes to oxidation number. Yeah, right. Okay, so while you are rewriting the rule, the 3 rules, okay, I also rewrite it once here. Yeah, rule number 1, all elements have an oxidation number of 0. Rule number 2, for ions, you have to memorize the charge lah, because the charge represents their oxidation number. Okay, rule number 3, first thing is about hydrogen. Hydrogen is -1 when with metal. Okay, the rest of the time is +1. Then oxygen in H2O2 should carry a charge of -1. Okay, but in any other time is -2. Hydrogen in any other time is +1. Alright, so these are the rules. Okay, so now we're going to do calculation. Right, first thing first, I have the compounds here. Okay, and in SPM, what kind of question they will ask you? They will give you this compound, and then among this compound, they will highlight or underline any one of the element in there. Alright, then they ask you to find out the oxidation number of the element in a compound. So how to do it is just simple mathematics. Very good. So in SO3, they want me to find out S. So what I do, I just use X to represent the charge of sulfur. Okay, because I want to find out X, that means S. So that means I don't know yet. Put X. And then the charge of S, I don't know what is it. Okay, I go and add it with the charge of 3 oxygen. 3 oxygen. This is SO3, 3 oxygen. Okay, so 3 oxygen. And what have you memorized just now? Oxygen in a compound is always -2. Alright, so I have 3 oxygen means I take 3 times -2. And then I equate to 0. Why do I equate to 0? Okay, how you see? Very simple, because after I write this formula SO3, there is nothing on top. I don't see any plus or minus or -1, -2, -3, no, nothing. So if here nothing on top of the formula of the compound, then that means you equal to 0. Now you just solve using simple algebra. Your X will be +6. So that tells you the charge of sulfur, or the oxidation number of sulfur in here, is +6. Okay, alright, that's how you do. Okay, now we'll be doing another example. Let's say this one. Okay, PO4 3 minus. This is a PO4 3 minus. Okay, and they want me to find out the charge of P. So as usual, they highlight the P means I have to make P and X now. So I assume the charge of P, phosphorus, is unknown X. Then I add it with the charge of 4 oxygen. So plus 4. Oxygen in a compound always -2. And this time round, I cannot equate it to 0. Just now I equate to 0 because after I write SO3, there's nothing on top I can see. But this time round, can you see this one is actually a PO4. Then on top, you can see 3 minus, right? That means the PO4, all their charges add up equals to -3. Okay? So this equation, solve it, you get X equals to plus 5. Alright? That's how it works. Okay? Alright. Next, let's look at another example. V2O5. So I need to find V and there's a 2 here. So that means 2 times V unknown X. Okay? Plus 5 of oxygen. Okay, oxygen in a compound is always -2. Equals to 0 because this time round I do not see anything. So settle this one. You should get 2x equals to plus 10. And since 2x equals to plus 10, so x equals to plus 5. Okay? So each V oxidation number is plus 5. Right, that's how things work. Okay? So this is about oxidation number. Okay. For the rest of these examples, please practice and check your answer. It's already given here. Alright, so this is about oxidation number. In the next lesson, we will use oxidation number to analyze redox reaction. Okay, so see you in the next video.